Hello and welcome to our today's lesson. We are going to introduce a new topic on right-angled triangles. On this particular topic, we are going to cover several aspects. One of them, we are going to review the Pythagoras Theorem. Two, we are going to look how we can be able to use the Pythagoras Theorem to find the shorter sides of a triangle. Three, we are going to learn how we can be able to use the Pythagoras Theorem to solve two-dimensional problem using Pythagoras Theorem to solve two-dimensional mathematical problems. Three, we are going to introduce what we call the trigonometric ratios. And on this particular subtopic on trigonometric ratios, we are going to learn about three aspects. That is the sine, cosine, and tangents. These are the common trigonometric ratios which we are going to look at. Next, we are going to look at how we can be able to use the Pythagoras Theorem to find unknown sides of a triangle. And the next thing that we shall look at is how we can be able to solve denominator problems. Or solving the denominator, which we are going to apply the trigonometric ratios in finding the denominator. Next, we are going to find unknown angles of a triangle. Finding unknown angles of a triangle. Second last, we are going to learn how to use the trigonometric ratios to solve mathematical problems. Using trigonometric ratios to solve mathematical problems. And then the last item that we shall cover on this topic is on bearing. All these subtopics brings up the importance of us learning the right angles topic, because it is applicable in so many areas or ways. The satellites that normally transmit information normally make use of bearings, and also some 2D and 3D theories which are developed by learning the right angle triangles. Maybe before we proceed into today's subtopics, we need to understand what a triangle is. A triangle is a three-sided figure. The name three, or this three, originate from part of its name, tria, meaning three. So it's a three-sided figure or diagram, which should also be a plane. Now, we have got three main types of triangles. One of them is what we call the right-angled triangle, which we are going to discuss in details. A right-angled triangle has a 90 degrees as one of its angle. So one of that particular angle should be 90. So if the other angle is A, then automatically this should be 90 subtract A. We have another type of a triangle called the isosceles. Triangle. And this kind of a triangle has two sides and two angles equal. So like if this is an isosceles triangle, this side and this side being equal, then automatically this angle and this angle, which are normally referred to as base angles, are going to be equal. So this is an isosceles triangle. Two sides and two angles are equal. We have the third type of a triangle called an equilateral triangle. And with this kind of a triangle, all sides and all angles are equal. So if that is A, this is A, that is A degrees. So all the sides and all the angles are equal in that particular case. It's called an equilateral triangle. And then we have got another generated type of a triangle, which we normally call it a scalene. Now with the scalene triangle, all the sides and all the angles are not equal. All the sides and all the angles are not equal. So if this is A, that is angle B, this is angle C. And if this is side A, that is B, and that is C, all of them are not equal. This kind of a triangle is normally referred to as a scalene triangle. We are going to consider, we're going to zero in on the right-angled triangles only. And this time round, we want to consider two subtopics on this topic during this particular lesson. The first subtopic which we like to cover is the Pythagoras Theorem. Let us try to understand the history of a person called Pythagoras. Now, Pythagoras was born in the Greek island a place or an island called Samos. That was in the early 6th century BC. Now this individual managed or was able to get privileged education, which enabled him to travel to Egypt and Persia. For his education. And he finally settled at a place called Croton, that is in Italy, where he founded a school. Now those people who attended Pythagoras school were referred to as the Pythagoreans. And they lived following very strict rules and a very structured way of life. The Pythagoreans, while studying in that particular school, were able to come up with the famous Pythagoras Theorem, which they named after the founder of the school, who was the Pythagoras. The famous formula or the famous theorem does states that if you have a right angled triangle, that being 90, that is A, this is the base, that is one of the other shorter side, then this is the longer side. Then if you take the square of the shorter side, you add it to the square of this other shorter side, you'll get the square of this longer side, which can be simply put as A squared plus B squared is equals to C squared. Now this is the famous theorem that originated from that school of thought of Pythagoras. They did a lot of and extensive detail in philosophy, philosophical studies, and applied so many mathematical ideas in solving their problem. During that particular tenure of studies, they were also able to discover some numbers which they refer to them as irrational numbers. A good example of an irrational number is root 2. And we all understand that irrational numbers are numbers which cannot be expressed as a fraction. They cannot be written in the form A over B, where A and B are integers, B not being equal to 0. And they are also able to note that these particular irrational numbers were neither terminating when you express them as a fraction, and they were never recurring. So when expressed as a decimal, they neither recur or they neither terminate. So they referred to those particular numbers as being irrational. Now Pythagoras, because of that inability of the numbers either terminating or having a tendency of repeating themselves, he decided to call those irrational numbers unthinkable numbers. He called them unthinkable, and therefore they were not supposed to be uttered by any who supported his school of thought. And if you are able to mention those particular irrational numbers like root of 2, then you are sentenced to death. The idea behind the Pythagoras theorem was that if that was our right angle triangle, this side being the base, this side being the height or the other shorter side, and then the longer side being referred to as C, then we can be able to come up with squares on all the three sides of this particular triangle. So you can come up with a square on that side of C. That means because this is a square, it's going to be a square of side C. Again, on the base or using the base, we can also generate another square, and because one of the side is B, then all the other sides are also going to be B. Again, on the height or the other shorter side, we can also develop another square of side A. Now, if you found the area of this particular square, you will find it to be length or side multiplied by side, which will give us C squared. The area of this other square will be a multiplied by a, which will be a squared. And again, the area of this lower square will be b multiplied by b, which will be b squared. Now, along the studies by the Pythagoreans, they discovered that if you took the area of these two squares, they will end up being equal to the area of one of the larger square on which was attached on the longer side of that particular triangle. And that is when they came up with the formula that if you take a squared, that is the square of the one of the shorter side, add it to the square of the other shorter side, the result will be equivalent to the area or the square of the longer side. This longer side of a triangle was given a name. The longer side of this triangle was given a name, and the name is hypotenuse. So that is the hypotenuse side. We'd say that this is the base, and therefore we can continue referring to it as the base, while this one will remain to be the height of our triangle. We have said the Pythagoras theorem, this is the theorem that a squared plus b squared will result or will give you c squared. Now, sometimes we may not have exact square root of numbers, and I've given a good example of the irrational numbers, root 2. If you are to get the root of 2, you'll discover that this number or the solution in decimal form will neither recur nor will either terminate. So it will be, you'll continue dividing without end. And in that particular case, we say that these numbers are referred to as irrational. And in case you have your answer in this particular form, which can neither be written as a fraction, then it is important that you leave it in this particular form. This form is referred to as the third form. And in this case, you'll be having the exact answer. Although sometimes the question might direct you to either write to a given number of decimal places. We want to find or to learn how we can be able to find the length of the longer side of a triangle, which is the hypotenuse. Example, find the length of the hypotenuse in this right-angled triangles. Part A, we have that as our right angle. We have been told that the base is 12 centimeters, the height is 5 centimeters. We want to find the hypotenuse or this particular length. Now we have said we make use of the Pythagoras theorem, which states that if you take the height squared of the triangle plus the base squared of the triangle, it's going to give us the hypotenuse squared. When we make this particular replacement of a and b in the formula, then a is 5, so we take the square of 5 plus the square of b, which is 12 squared, should give us c squared. Now when you get the square of 5 is 25. 25 plus the square of 12 is 144. Again, this is equals to c squared. Now when you add 25 to 144, you'll get 169, which is equals to c squared. So this tells us that our c squared is equals to 169. And therefore, for us to get the value of c, we need to get the square root of both sides. So we get the square root of the left hand side, it will leave us with c is equals to the square root of the right hand side, it will give us 13 units. Therefore, we can be able to say that c is equals to 13 units. Part B of the question, we have a right angle triangle of that form, where that is 9.5 centimeters. The other shorter side is 7 units. Then we need to get c. Again, we said we use the Pythagoras Theorem, a squared plus b squared is equals to c squared. Now, these are the sum of the squares of the two shorter sides. Therefore, we take one of the shorter side is 9.5, so that will be 9.5 squared, plus the other shorter side is 7, so we take 7 squared, should give us c squared. When you get the square of 9.5, you'll get it to be 90.25. The square of 7 is 49, is equals to c squared. When you get the sum of these two, you'll get 139.25, which is equals to c squared. That means that our c squared is equals to 139.25. For us to be able to get the value of c, or the longer side of this particular triangle, we need to get the square root of both sides. So when you square the left hand side, that is, when you get the square root of the left hand side, that is c squared, we'll get c. And then when you get the square root of the right hand side, you'll get 11.80042.372. Now, in this particular case, we are allowed to round off, and always round off depending on what the question requires. If you're asked to round off to the nearest 2 decimal place, round off to the nearest 2 decimal place. Let us round off this value to 4 decimal places. That means we count 4 digits after the decimal place. That will be 1, 2, 3, 4, and we consider the 5th number. If it is 5 or more than 5, then it's going to add 1 to the preceding number. And because the 5th number is 2, which is less than 5, it's not going to affect our preceding number. Therefore, the answer will remain as 11.8004, and this is to 4 decimal places. Find the lengths of the length of the diagonal, steel brace required to support a wall of length and height 2.6 meters. Give your answer. Correct to 1 decimal place. Now, the solution to this question, have been told to find the length of the diagonal steel brass required to support a wall of length 3.5 centimeter and a height of 2.6 meters. We are supposed to give our answer correct to 1 decimal place. Now, if this is our wall, which have been told is of length 3.5 meters and the height of the wall is 2.6 meters, we need to find the length of the diagonal of the metal or steel brass, which will be required to support this particular wall. Again, you discover that when you do that, this will be a right angle triangle, and this will be the longest side of that particular triangle, or the diagonal will be the longest side of this particular triangle. Therefore, you can be able to use the Pythagoras Theorem to determine or come up with the length of this steel brass that will be required to support that particular wall. We have said s squared plus b squared is equals to c squared. That is the Pythagoras Theorem. The two shorter sides, one is 3.5 meters, so that will be 3.5 squared, plus the other one is 2.6, so we get 2.6, we square it, it will give us c squared. When you get the square of 3.5, you'll get 12.25. The square of 2.6 is 6.76, which is equals to c squared. So this means that c squared is equals to, when you sum that, you'll get 19.01. For us to be able to get the value of c, we need to get the square root of both sides. And when you get the square root of the left-hand side, you'll get c. When you get the square root of the right-hand side, it's 4.360045,871. But we have been asked to give our answer correct to one decimal place. So we count one figure after the decimal place and we consider the next figure. So the next figure here is 6, which is more than 5. Hence, it's going to add 1 to the preceding number, and therefore this can be approximated to 4.4 meters. And this one is to 1 decimal place. Therefore, the length of this particular metal brass that is required to support the wall of length 3.5 meter by 2.6 meters is 4.4 meters, rounded off to the nearest 1 decimal place. Last example on how to find the length of the longer side. That's example 3. We are told find the length of the hypotenuse. Leaving your answer in exact value. Part A of the question, we have this right angle triangle where this is 1, that is 2, and we need to get C. So we said in this particular case, if we need to get the longer side or the hypotenuse, we use this particular formula or the theorem, Pythagoras theorem, which is s squared plus b squared is equals to c squared. The two shorter sides are 1 and 2 units. Therefore, when we get the squares, this will be 1 squared plus 2 squared is equals to c squared. When you add square of 1 to square of 2, that will be 1 plus 4, which will be 5, is equals to c squared. This means that c squared is equals to 5. Now, for us to be able to get the value of c, we need to get the square root of both sides, which will give us c on the left-hand side is equals to the square root of 5 on the right-hand side. Now, if you get the square root of 5, you will find that that number is neither terminating or recurring. Therefore, you cannot write that number as a fraction, and we refer to them as irrational numbers. And therefore, if we want to leave our answer in exact value, then we need to leave it in surd form. Now, this is what you call the exact value of the hypotenuse. So it is root of 5 units. Part B, we have that this is the longer side, these are the two shorter sides. We are told that that is 3 and this other one is 5 units, then the longer side is C. So again with this, we again use the Pythagoras Theorem, a squared plus b squared is equals to c squared. We add or we get the sum of the squares of the shorter sides, which will be 5 squared plus 3 squared is equals to c squared. When you add 5 squared is 25, 3 squared is 9. So when you add 25 to 9, you will get 34. So this means that c squared is equals to 34. And therefore, for us to get the value of c, we need to get the square root of both sides. When you get the square root of the left-hand side, you'll get c is equals to root of 34. Now again, that is an irrational number, that is 34. But always in third form, try as much as possible to simplify. In this case, we will be forced to leave our answer as the root of 34 units. We now want to proceed and look at another subtopic on how we can be able to find the shorter sides of a right angle triangle. Finding shorter sides of a right angled triangle. We had said that if this is our right angled triangle, this being the base, this being the height, and that being the hypotenuse, then these two are our shorter sides. And we had said that the Pythagoras theorem states that a squared plus b squared is equals to c squared. That is the square of the shorter side. The sum of the square of the shorter sides is equal to the square of the longer side. Now we are interested in finding either a or b, which are the shorter sides of our triangle. And in this particular case, we'll seek to make either a or b to be the subject of the formula. So in this case, if you want to find a, for example, want to find a, then we need to take b squared to the other side of the equal sign. That means we subtract b squared from both sides. This will give us a squared plus b squared minus b squared is equals to c squared. Whatever we did to the left hand side, you must also do it to the right hand side. And therefore a squared is equals to c squared, subtract b squared. Now for you to get the exact value of a, then you need to get the square root of both sides. So we get the square root of the left hand side and the square root of the right hand side. This will give us that a, which is one of the shorter side, is equals to the square root of c squared subtract b squared. Now the same applies when you want to find b. So if you want to find b, that means we eliminate a on the left hand side, and for us to do that we subtract it on both sides. So we shall have a squared plus b squared minus a squared is equals to c squared. Whatever we did to the left hand side, you also do it to the right hand side. This will leave us with b squared on the left hand side is equals to c squared, subtract a squared on the right hand side. And therefore, you to get the exact value of b, we need to get the square root of both sides. When you get the square root of the left hand side, it will give you b is equals to the square root of c squared minus a squared. So these two particular formulas are the one we are going to apply in finding the length of the shorter sides of a triangle. Example, in each of the following, find the value of the pronumeral round your answers we are supposed to round our answers to 1 decimal place. Let us put it as 2 decimal places, and this is where necessary. Part 1, we have this triangle. It's a right angle triangle. The longer side is 17 units. One of the shorter sides is 15 units. We have not been given this other side called A. Now previously we had said that from that particular formula, A squared plus B squared plus C squared, we can be able to generate a formula for finding A. Or what we simply need to do is substitute those particular values. Since we know what A and B are, they are the length of the shorter sides, we can easily substitute. Now we don't have the value of A, we have it as, so we can retain it as A squared because it is the pronumeral that we are looking for, plus B squared, which is the length of the other shorter side, which will be 15 squared, this was equals to C, is equals to C squared, and our C is 17, so we shall have 17 squared. This will give us A squared plus 15 squared is 225 is equals to 17 squared is 289. Now for us to get A squared alone to be on the left hand side, we need to take this 225 to the other side of the equal sign. That means we subtract 225 from both sides. This will leave us with A squared on the left hand side is equals to, when you subtract 225 from 289, you'll get 64. Now for us to get the value of A, we need to get the square root of the left hand side and the square root of the right hand side. This will give us that A is equals to the square root of 64 is 8 units. Therefore, that means that this shorter side is 8 units. Alternatively, we could have just substituted into our formula direct. Our formula for finding A was the square root of C squared minus B squared. So this would have been given us 17 squared, subtract the other shorter side, which is 15 squared, which will have been the square root of 64, again, which will have been 8 units. So the two methods or approaches are accepted. Part B of the question. So the question remains, we are supposed to find the shorter side of a triangle, and this is now part B. That is our right angle triangle. That is X units. This is 7.6 and this is 10 units. We can simply put or substitute this into a formula. One of the shorter side, X, is equals to the square root of the longer side, which is now, the longer side is 10. So that will be 10 squared, subtract one of the given shorter side, which is 7.6 squared. When we do this, you'll get x is equals to the square root of 100, subtract square root of 7.6 is 56.6. X will therefore give us 100 subtract 56.6 is the square root of 42.24. Now when you get the square root of 42.24, it will be 6.499230.724. But the question told us that where necessary, we are supposed to round off our answer to the nearest 2 decimal places. So what we need to do, after the decimal point, we count 2 decimal places, then we consider the third figure, which is more than 5, therefore it's going to affect this. So that will be 10, we put there 0, we carry 1, so this one will be added to 4. So this answer of the value of x can be approximated to 6.5 units. Example 2. In each of the following, find the value of the pronumeral. Pronumeral simply means the unknown term or figure. We have that right angle triangle. You are told that the longer side is 20 units. The height is 12 units, and this other part is A. We need to find the value of A. We said that using the Pythagoras Theorem, one of the shorter side in this particular A can be given as the square root of the longer side, subtract one of the square of the other shorter side. So in this case, our A, which is the pronumeral in this case, will be equivalent to 20 squared, subtract B squared, which in this case is 12 squared. That means that our A will be equals to the square root of 20 squared is 400, 12 squared is 144. When you get the difference, A will be equal to the square root of 256, and when you get the square root of 256, you'll get that A is 16 units. So this tells us that one of the shorter side of this particular triangle is 16 units. Part B. We are told that this is B, which is the pronumeral we need to find. Then one of these other shorter side is 2.3 units, and then the longer side is 5.6 units. Again, when we need to get the value of B, we said we find the square root of the difference of the longer side and the shorter side. The longer side is 5 squared, so we get 5 is 5.6, therefore we get 5.6 squared. We subtract the length of one of the shorter side, which is 2.3, and we square it. So the difference, that is 5.6 squared, subtract 2.3 squared, will give us the square root of 26. 26.07 units. When you want to get B, we must get the square root of that particular right hand side, which will give us that our B is 5.10587896 4, which we can also approximate it to 5.1059 to 4 decimal places. Now we have found the value of B to be 5.1059 units when approximated to 4 decimal places. The base of a ladder leaning against a wall is 1.5 meters from the base of the wall. From the base of the wall. If the ladder is 5.5 meters long, if the ladder is 5.5 meters long, find how high the top of the ladder is from the ground, and express your answer correct to 1 decimal place. Now, solution to this question, we need to come up with a diagrammatic representation of the question. We have been told that we have a wall, and this particular wall, we have been told we don't know the height, but the distance from the base of a wall to a ladder that is leaning on this particular wall, the length of the ladder is 5.5 meters, and the distance, the base of a ladder, this is the base of the ladder, leaning against a wall is 1.5 meters from the base of the wall. This is the base of the wall. So that means that our shorter side is 1.5 meters. So you'll find that the ladder leaning against the wall forms a right angle triangle of that particular nature. Now we need to find the height of this wall using the height of the ladder, or the length of the ladder, and the distance, or the base distance from the base of the wall to the base of that particular ladder. So in this particular case, we are looking for one of the shorter side. And in this case, we say that if you take h at the sum of the two shorter sides, that is h squared plus this other one is 1.5 meter square, should give us the square of the longer side. So this means that h squared will be equal to 5, and it's the square. 5.5 squared, we subtract 1.5 squared. That is when collecting the like terms. So that means that our h squared will be, when you take 5.5 squared, you subtract 1.5 squared, you'll get 28. So this means that our height will be the square root of the right hand side, which is the square root of 28. When you get the square root of 28, you will get that h is equals to 5.2915022622. But the question requires us to write our answer correct to 1 decimal place. So we count 1 digit after the decimal place, and we consider the third one. It's more than 5, therefore it's going to affect 2. So height will be approximately equal to 5.3 meters, because the units in this case was meters. It's also important to note that whenever we have units, always put them in the correct or the required units, because length is always measured in centimeters, meters, kilometers, and so forth. Final example on finding the length of the shorter sides. That is example 4. Find the value of x in the diagram below. Find the value of x in the diagram below. We have a trapezium. We're told that that is 18 units. This is 14 units. That is x units. And this is 12 units. We are also given that the two sides are parallel and that these two sides are equal. That means at the center we are going to have the length which is 12, leaving 18 subtract 12 to be shared on the other two sides. So that means from here up to here it's going to be 18 subtract 12 divided by 2, which will be 6/2, which is 3 units. So that means that this is 3 units, that is 3 units. And because we need to find the value of x, we need to know what this other value is, because this forms a right angle, also this forms a right angle. For us to be able to know this height of this small triangle, we can be able to use the other side of the triangle, because it has two sides, one short side and the long side. So we can be able to find h of this particular triangle first, and our h will be given by the square root of the longer side squared, subtract the square of the shorter side, which will be equivalent to the square root 14 squared minus 3 squared is 187. And because when you get the square root of 187, it will be an irrational number, and we want it to be exact, you can leave it as that. So this particular height is root of 187. And because this line and this line are parallel, that shows that their distance on either sides are going to be equal. Therefore, so this one is going to be a root of 187 units. And now we can be able to use this triangle to find the value of x, which is the hypotenuse of this particular triangle. X will be given by the square root of the sum of the squares of the two shorter sides, which will be 3 squared plus 187, root of 187 squared. Now this will give us 9 plus 187, which will give us that x is equal to the square root of 196. And we all understand that square root of 196 is 14. So x is 14 units, which is more or less to what we have on the right hand side. Now this brings us to the end of the discussion on the Pythagoras Theorem on how to find the longer side and the shorter sides of the triangle. When we meet next, we shall learn how to use the Pythagoras Theorem to solve two-dimensional problem. So important to note, is the Pythagoras Theorem, which states that if you take the sum of the squares of the two shorter sides of a right angle triangle, it will give you the square of the longer side. And that means if you want to get C, which is the longer side, you get the square root of the sum of these two other side. And we have said if you want to get A, you get the square root of the longer side minus the other square of the other shorter side. If you want to get B, it's again the same. You get C squared, which is the square of the longer side. You subtract the square of the given shorter side. Thank you.